In the previous videos, we mentioned about the limitations of a research design, which we know that a typical research study, there will be measurement involved. However, this measurement itself only provides informations which reflects parts of the facts. It is up to us to interpret, synthesize based on what we have known from the literature in order to conclude findings. And this finding that you have acquired may not be fully accurate. Therefore, you know that you need to carefully design your research to be critical, accurate, and acquire adequate information for you to describe the subjects that you are studying in order to minimize misunderstanding of the actual situations. Knowing these limitations, you might want to ask, how can you realize this in your research design? In these videos, I'm going to introduce you a bit on an example methods trying to overcome these limitations. We may not be able to acquire 100% results totally identical to the actual situations. At least we can try ourselves understanding the situations as close as possible to the actual conditions. This approach is meant to increase our level of understanding, which are commonly used in engineering research. And then you need to know that in order to do that, you need to have a good mixture of different approach for you to study your topic. You are encouraged to use more than one approach for you to study a topic. First is to cross-check each other. Second is to complement each other. With that, let us look into detail of this as given in this slide. First, in the engineering research, there are several approaches that you can use to study a topic. For example, you can do experiment, you can do analytical study, you can have numerical studies, and others. The experiment is you fabricate the actual specimen or you produce the prototype, and then you conduct investigation program over those specimens or prototype in order to gain better understanding. And this specimen and prototype is to your best capacity to simulate the actual situations, including the load cases. As for the analytical study, it involves derivations of the equations on basis of the first principles, going through a process of mathematical derivations in order to represent the relationship between the parameters. As for the numerical study, it will be like simulating situations by using computer program, which involve modeling of the things that you would like to study, as well as simulating the conditions applied onto those things. These are the three common approaches that you can use to study a topic in engineering research. There could be more that you will need to explore yourself. Now you may use more than one approaches for the investigations. Of course, the more approach you have, it will be better, as it gives you a more thorough pictures of the subjects that you are studying. Only that, when more approaches involved, more efforts and time will be required. This one you will have to find a balance in between the amount of time that you have versus the number of approaches that you can use for your investigations. I would say that for the most basic investigations, maybe you use either two of the three. You can have combinations of experimental and analytical study, or experimental and numerical study, Or you might want to have analytical versus numerical studies. Or you can have all. You know that the research project is rather unique. Different cases will have different ways to address it, and it is very dependent on the purpose and the objective of the study, as well as governed by the capacity of the researcher, whether he or she is able to handle it, as well as the existence of the facility available within the institutions, and so on and so forth. Therefore, there will be quite a variety of ways for you to understand the situations through different combinations of the approaches. And when you combine those approaches, you may not necessarily to have the amount of work to be equally divided. Let's say now you are doing experimental and analytical study. It doesn't necessarily 50% for experiment, another 50% for analytical study. It is depending on your emphasis. Sometimes you can have 70-30 or 80-20. The meaning of 70-30 is you may have your experiment cover a broader aspects of the subject that you would like to study, and then for the analytical study, you only focus on the critical area which you have already identified through the experiment. In that case, you don't have to replicate the entire experiment in your analytical study. Or maybe you want to conduct your study by putting emphasis on numerical study and then complement by the experimental study. That means now numerical study will be 70 and experimental study will be 30. Therefore, you will do numerical study to cover a broader aspects, trying to understand the subject that you would like to study, and then you conduct experimental study for verification purpose, as well as to obtain informations which cannot be acquired from the numerical study as a complement to the numerical study. The idea now here is to put the pieces together, and there will be areas of overlapping and there will be areas of non-overlapping. For the areas of overlapping, you can use to cross-check each other as a method for you to do the verifications or validation purpose. If you observe all the overlapping areas, they are perfectly in line, you will assume that the non-overlapping area, as given by one of the methods, it will be the additional informations provided by that particular method, complementing the understanding to the topic of study. The figure here gives you an overview, demonstrating to you that how different methods can complement each other. Let's say now your study is focusing on the experiment and analytical studies, which are built on the understanding that you acquire from the literature review, which is considered as the conceptual. Each of these create a single line of understanding on the subject that you are studying. From the literature review, you acquire the concepts, you know the first principles, you know the relationship between the parameters, you know how the parametric will respond, and probably you gain explanations on the final outcome. As for the experimental study, you conduct testing, you do measurements, you acquire results, and you conduct measurements, you acquire another result, and you acquire your failure mode. As for the analytical study, you start deriving your equations on basis of the first principle, and then the process of derivations step by step until you reach to the final equations. These derivations is sometimes on basis of the literature review, probably based on the theories proposed by the previous researcher, or on basis of certain understandings or observations, and you derive through the equations. And then you will see every single approach here have their line of understanding. You compare those understandings. You will see there will be overlapping parts. There will be stand-alone parts. For those overlapping, you will use them as methods for you to cross-check each other. As for the individual part, it will give you additional informations as long as you've done the verifications, found out that all the overlapping parts are in line to each other. Let's say now you have 3 lines here. You will need to check the consistency between 2 of them, whether they are in line, and then check consistency of another 2 of them, whether they are in line. And then you know that all 3 now is talking about the same thing. Now you can put the pieces together. When you have more than 2 parallel informations as contributed by different approaches, such as this, you will need to check whether they are in line. When you have one unit which are unable to be given by the other 2, you know that that will be the new informations as offered by one of the approach. You will use this one unit to fill in the gaps. Sometimes it can reach to a conditions where none of the methods are able to provide answer on certain thing. That will be the missing link. And you might need to seek answer from the literature review, doing more review of the literature, or if you still can't find the answer, probably highlight this, provide recommendations for future studies. Sometimes in order for you to complete the understanding of something, you will have to fill in this missing link. Based on the prior understanding that you have acquired, you might want to propose some assumptions and clearly indicated that those assumptions are to be verified in the future study. With that, you are able to acquire a series of findings for you to draw the conclusions. You know that experimental study is mainly on the observations. What happens to the specimen you observe, interpret, and you try to explain. As for the analytical model, there will be 2 parts: developing the model, cross-check with the experimental result for validations. Once it is validated, you will dig into the model, observe the relationships in order for you to find new insights within the model, trying to explain these situations. Then you will be able to acquire finding which is contributed from the literature review, from conceptual, from the experiment through observations, from analytical model through predictions and projections. Having these to demonstrate how you can play around with different approaches, I hope you have gained better ideas how you can design your research, how you can use different approaches to complement each other. As postgraduate study is actually dealing with rigorous research study, normally it is recommended to you to have at least one approach for the investigations. It will be quite difficult for you to justify, to prove your experiment is correct by using the experiment alone. It is also difficult for you to justify your analytical model or your numerical study is actually accurate by using themselves to prove themselves. To save the hassle arguing with your supervisor or the examiner, you can go for a conservative way to have at least one approach, cross-checking each other, especially at the regions of the overlapping, And then there is the advantage of having at least one approach where they can give you additional informations on top of what you have acquired from one of the approach. This can increase your credibility and it will be more persuasive to your supervisor and the examiner.